Just so we solved the advent of code today already, right? And I was starting to introduce the place expressions, but then I needed to go, and now I'm back, and we're going to continue working on that stuff. So yeah, we're going to introduce the references because I cannot leave this unfinished before tomorrow. I think I don't know actually how much time this is going to take. We'll see. Hello, Nerdzel, again, I guess. That's the first one. Maybe the other people are asleep. So they didn't come to claim the first before you. That first double stream. Hello, Nigel. Again. Alright, I'm going to continue. Just work on the place expressions here. Alright, so we have a print place reference, which is going to be printing the ID. Let's actually, you know what? Let's print this. FMT place this. I think I like that. Hang on, Exodus is something with category theory. I'll be right back. Sure. Yeah, I saw that. I clicked on that stream too. Function FMT place. So, and in case of a value, it's going to be like this. We're going to match place value with something. Oh, and then going here too, yeah. By the way, place value, right? This is an option, but I think I want to have here not an option, but like place state, you know. And I will say that place state is either not like uninitialized, because that's what we're going to have in the future. We either initialize we start with not initialized place, then we have the value there, right? So we have like, what do I call it? Occupied, I guess. Uninitialized, occupied with value. Or the place, like, eventually we will have move semantics and we'll be able to move the values out. So it will be a moved out, which is a little bit different than uninitialized. I mean, it's the same, but for the sake of error reporting, it's different. Right, star, after you started break, I get a compiler error from clang for C talking about L value. I see. Are you writing C right now? I thought you were a Rust programmer. Wait, did you reply what the state of your language is? Did you start making it yet? And whatever. I don't remember the answer. The language was being written in OCaml, then Rust, then Haskell, then Gleam, now C. Oh shit. Why would you go into C though? That makes no sense to me, to be honest. Why would you go into C? Missed imperative? Yeah, but C? Like, I don't know, at least Zig. Why not Zig at least? I should copy Kubi in everything he does. Oh yeah, he already copied my my trait system. Pretending that didn't see it before. All right. Let's see. Yeah, over here, right? So print value, we're going to match the place value with Actually, you know what? It should not be place value. This should be place state. That's what I should call it. State. Because it's a place state. State. There we go. So we match place state with either uninitialized, then we say uninitialized, right? Then if we say occupied value, then we print value. And if it is moved out, then we print moved out. There we go. So cast glue and Siri writes coming soon. No, the next rewrite is cast in cast, and maybe then you can write your language in cast too. Yeah, I don't know. Just wait till you go back to OCaml. Probably won't happen. Didn't have a nice taste in the mouth with the constant match and untyped exceptions. Yeah. That's not the biggest problem with OCaml. For me, the biggest problem is the fact that I literally have to, like, I don't know, to define recursive things. Like, certain things are like just not expressible without the recursive functors, and recursive functors suck. You enjoy typing so much? Don't know why I said that when I'm writing in C. Yeah. No, I mean, it's just like, yeah, it could be better, but there are other bigger issues with OCaml. Recursive functors, yeah. Functors in OCaml are not exact. Like, functors in OCaml is basically generic modules. That's what it is. Right? So, for example, you have a set of integers, right? You have the module integer, which defines what an integer type is. How do you compare the integers, right? Now, using that module, you can create a set of integers, which means that the set, in like the generic set, takes a module as argument. That makes a set being a functor. So it's a function on the modules, right? And then I want that to be recursive sometimes, because of the recursive nature of my language, and that is the very painful in OCaml. Field. Okay, so over here, when I'm printing the tuple fields, I print place value, field place. There you go. So that's what I do. Let's go next. Inference, when we have value tuple and value tuple. Interesting. Now we have the inference. Now then the inference, so I need to unite two places together. Uniting two places together is something that is not making a lot of sense. So if I'm uniting the value tuples, I guess what this means is that I'm just going to construct a new place there. You know. Yeah, and I feel like I need to have, after all, the place new, right? Place init. Right, with value is ID is idgen, value is some value, I guess state is occupied value, and then there is the type. I'm actually wondering if my places should have the types. Should my places even have the types? You know what? Let's for now keep the type out of a place. That makes sense to me right now. So here I say that place is a place init, using unite value. I mean, okay, fine. Let's say over here unite place span A place and B place. Sure, let's do that. And unite place is a place unite is span AB. So I'm just going to say that let A is let A is get value A. Let B is get value B. Right, and then we say place init unite value AB. That's what I want. And then we will have the function get value, which takes place and returns value. So that's going to just be match place state with, if it's occupied with value, then I'm just going to return the value. But if it's uninitialized, then I'm going to throw an error here, saying that uninitialized variable place it's something something. It's probably good enough. And then if we say moved out, then moved out place, sure. Hello, what language am I using? I'm making my own language, and I'm using OCaml here to implement it. Expression has type unit, but expression was type of value. Yeah. And so like in this case, we will say error value inferred span. That's what I want. I guess. Okay, and then over here, when I infer the value shape, okay, this is going to be place is place initialize with a new not inferred value of this type. Yep. That is nice. What's next? Yeah, the type of value shape. Is this even used anywhere? Type of value shape. Is this used? the shape type of inferred value. Yeah, if I have the shape, then yeah. This value shape, and I should have the type of it. And for that to work, I do need to know the type of a place, even if it is moved out. So do I add it back? Sure, I add it back. Type is type. Fine. Unbound module value. Unbound module value. Where is the module unbound? Here? Oh, yeah, because it's not value inferred, this should be like inferred value in this place. Unbound module place. Place. Yes. Because now I need to be able to create the place. Right? Yeah. Let's say init is init place. Let's do that in the types here. I just say let init place is this. I guess after I include that, and then we say that type is okay. I guess it's not here. I guess it's in the inference impl after all. That's where I am initializing the place because type of value shape. Wait, no. Type of value shape. Yeah, because I need like value dot type, right? That's the type of my value. Sure. Not like really recursive, but sure. Let's put it in the inference for some reason. So we don't do place init, we say init place here. And yes, init place. All right. Interpreter scope. So now in the interpreter, when I'm saying that I added a local, didn't I comment this out? I'm pretty sure I commented this out earlier today. Okay, let's just do place print value of local place. Let's do this. Print value is print place value. Is that not a thing? Print place value. Because of the recursiveness, yeah, that makes sense a little bit, I guess. Let print print place reference is with cache impl print place reference, and print place value is print place value. Okay, there you go. So add locals, we just print the place, right? Yeah. Also, I guess we can still keep print reference, place value reference. Sure. Maybe I should still, like, you know, over here say that this is a place, and like whether it's like I should still tell its state, I think. Yeah, let's actually match. Like in this case, we just don't print the type itself, Dev Ninja.
Hello, Dev 9-inch nails, yeah.
Dev 9-inch nails, I mean. I'm sorry. Hi. Moved out. Uninitialized. Or occupied. Right? We do that. And then after that, we also print space ID print place ID. There we go. That's what I want. So we ignore the value in this case, and we close the Angular stuff. Okay, interpreter scope. So when I'm adding a local, I'm adding a value. In this case, I initialize a new place, right? Yeah, place ID. So instead of doing this, I'm just saying place init a value, right? There we go. Now here in the substituting bindings, this is okay. This is tuples. Let's start with. I think I should start with maybe. Yeah, let's mesh place state, right? This is occupied value. And this is uninitialized or moved out. Try to use binding. Try to substitute binding. Try to substitute with place print. In this case, it doesn't really matter. Place. Mm -hmm. Okay, so what is this again? This is me also substituting the value. Yeah, that's the same stuff. Local place state, if it's occupied, or if it is uninitialized or moved out. Try to substitute with this place print local place. And then this over here, this is my tuple. So tuples have places instead of values in them, and over here place, going to substitute place, right? Fine. Sure. Let's say substitute place. Oops. And then we say that. Substitute place. Twitch told me you're live. Nigel did. Twitch sucks so hard at push notifications. Twitch did not tell you that I'm live. Okay. State and place. This was going to give me the place back. So what is this? I'm going to match state. I'm going to match place state. If it is occupied. If it is occupied, then I'm just going, occupied with value, and then I'm going to say that we return place in it with sub value, state value. But if it is uninitialized or moved out, what do I do then? I think I just return the place back. Well, actually, place initialize with state place state. I think maybe I still want the original one. Not sure. But let's have the init state anyway. Oh wait, but in this case I need the type. Place type. But init state type is id state type. This record expression place. There is no this thing. Yeah. So over here, this is pattern matching. I'm creating a new thing here. So I do place init with value. What's next? A lithography stream making a CPU. I mean, after the language is done. No, I don't go that deep. We make games. We make our own custom game engine in this language. Then reading stream for dependent types. Nah, there's no way I'm doing more reading streams. Just maybe a little bit of reading, like 5 minutes of reading, no more than that. Value type field value. Okay, this is what? This is pattern matching. Yeah, so when I'm pattern matching against a tuple, so we have field value, pattern match. Yeah, and this is why pattern matching should take a place, because fields of the tuples are places. Yes, that makes sense. So like pattern matching, we should actually match places with patterns, and we only take the value out of a place if needed. You're making your language more complex every day. Are you sure that you will create an engine? I mean, that's the yeah, that's what I want to do. What do you mean? I already created the engine, but like it's right now written in Rust. I just need to finish the language and then rewrite it. Making the language more complex is what allows me to create an engine, yes. Making an engine in a simple language would suck, because simple languages are bad. They take too much work to write programs in. Okay, yeah. Place. Pattern match binding. So in this case, we yeah. So I need to like say place. So I need to like take place. Like this is my original place. Yeah. This is my original place, and then I initialize a new place while taking it out of the previous place. So we say place take, right? Or let's say claim here, right? That's the Rust semantics. We claim this place, which can like either copy or move the value out. We claim this place. And type field is type of value. In this case, it's just going to be place type. Agile DC. Why are you guys talking in Discord and not in my chat? Is that how Nigel ended up stealing my idea for traits? What are you guys discussing in the Discord? Place claim. Yeah, so like what is claim? Claim is basically this. I didn't steal them. They are not called traits, they're called abilities. Well, I mean, I don't even have the name for them, right? They are just types for me. I guess. I mean, yeah, yeah. I did not really call them traits. I'm not sure if I need a dedicated name for those. Ability sounds like an effect system. You also want to steal the ideas from me? All right, let's see. Let's see. Claim. So claim place is going to give us the value back. Actually, you know what? That should be part of the interpreter. Claiming should only be implemented in the interpreter. That's yeah. Claim place. Let's just do that here. So I'll just say that claim place gives us value back. That's going to be, and I need to have a span here, I think, in order to do the error reporting. So we're going to match place state with if it's occupied value, then let's do the proper implementation here. If copy type if is copy type place type, then we just return value. Otherwise we will return value, but before returning value we are going to say that place state is moved out, right? Yeah, and then if it is uninitialized, then we will throw an error. Tried, I mean, place is not initialized. And if it is moved out, then we say place has been moved out. Moved out of, I guess, right? Because the value moved out of the place. Uninitialized, moved out. Is that a typo? I had the typo originally. Initialized. I broke everything. But I broke everything because OCaml language server sucks. Because it did not rename it over here. And it did not rename it over here. And it did not rename it here. Nice renaming functionality, OCaml language server. Okay. Now, is copy type for now? I'm just going to say that is copy type is just always true. This is going to be changed at some point though, but for now everything is copy. Place state, this should be like a left arrow, right? A previous solution, when you think about it, this is the most straightforward way of doing it. My previous solution was to be able to introduce an implicit argument to function, but that is unnecessary specific. I'd go back to that though, then I don't need to parse the entire function body before knowing it needs a trait implementation. Well, that's why, I mean, yeah, it's part of the signature. You don't need to parse the body, right? Like in Rust, you say, well, I guess, yeah. Yeah. I actually might do something similar myself for now, for the, like, before I have the trait solver, basically. Copying me? No. Not exactly like that. Not exactly like that. Like, I mean, it will be inferred, actually, right? But you should be able to do that yourself. It's going to be like, the implicit argument that you're talking about is the context system in my language, right? So it's you who are copying me, right? Okay? I call it context system, and then you call it implicit arguments. I mean, it's the same thing, kind of, but not exactly. And it's supposed to be inferable, too. But, yeah, we just pass the traits through the context system. You'll call it cast abilities, okay. Call it spellbooks. Okay, claim place. Claim place. Claim place. Span. Span is well, I mean, if I show the span of the pattern, then that's not the correct span. I want to pattern match where this place came from. So I think maybe when I pattern match, I need to give it the span. Actually, that makes sense. Like, what is the span of the thing that I'm trying to match? Of this place. Actually, wait, it's not implicit arguments. I'm not copying you. It's explicit argument, as you can see. Header. Okay. Yeah, you're saying that you are going to do the implicit arguments using explicit arguments for now, because implicitness requires parsing function body. Yeah. Like inferring the implicit arguments. Or you're saying that it's going to be explicit on the function definition, but implicit on the function application. That's how Scala does it, I think. Look at Scala and what it does. And I think that is also the way OCaml is supposed to work. There is the OCaml modular implicit proposal, which is proposal from like 10 years ago, but like they are supposed to, like they want it, and as far as I'm understanding, they want to add implicit modulars, right? No. Wait, where is modular implicits? Modular implicits. There's a website for it. There you go. This one. It's an extension of OCaml, enabling ad hoc polymorphism. It was introduced in the paper in literally more than 10 years ago. And then in 2023, they finally tried to start implementing it. So yeah, let's say that you want to print a like show is basically how you print. This is from Haskell, right? A type class. And then you just have implicit argument of type showable t, right? Which means that you just need to provide the argument and then it's just going to be printed because we already have it implicitly available, the implementation of the show. And that's literally what you want to do. You just replace implicit keyword with the what did you use, like the at symbol? Yeah, and you say that because you replace the implicit keyword with the at symbol, it's not longer implicit. All right. Unbound value. What is value? Yeah, we have place. Tuple. Yeah, if I'm having a tuple, then I guess in this case, I mean, that's why Kuvi says cast is the language. Yeah. So we need to do place claim. Sure, let's claim it for now. I don't want it to be claimed here yet though, but sure. So then we do pattern match, field value. Let's see, field value place. That is the place. What about the span here though? Guess that is the original span still. Okay, if we have a variant, we also say place claim and that. Expected tuple got this. And let's see, place print. No, this is value here, right? Yeah, there we go. Wait, no, this is value shape. Value shape print. Place claim. Pattern match. Yeah, this is also like a little bit weird. It means that my variant would have data, which is an optional place now. Value variant. This is an optional place. Give me a minute. I've been stuck with my work for hours without go to bathroom, but he usually casually went there. But I cannot go right now. But you can watch Twitch. You can watch Twitch, but you cannot go to bathroom. What kind of work is that? Twitch viewer? Do you work as a Twitch viewer? I don't know. Right, where was I here? So we have data, and this should be place, and then we substitute place option map. Substitute place state. We can do that too. Okay, call untyped function. When I'm calling an untyped function, how rude? How rude? How rude? What's rude? It's rude to not let you take a bathroom break. That is rude, right? Pattern match. Yes, I'm pattern matching here at the span, which is span. I mean, sure, span. The span where I would call the function from. Okay, so now the argument with which we call the function is a value. Should it be a value? When we call a function, I mean, yeah, that would make sense. That would make sense. We do place init in this case. We initialize the place with this thing. It's like a temporary. Yes. Assign. When I'm assigning to a place, then we say that place state is occupied value. There you go. When we say let pattern, we just do pattern match at the span. So this is a value. Assign state expression assignee value. But the span would be what? The span of the assignment. Like, I feel like I should take the span as argument here too. And the value. We don't assign. Assign is to values. We assign to the assign is the places. So the thing on the right is always a place expression. Place. Yes, so if I am assigning from one place to another place, it will make this one occupied, but we say that value is evaluate is claim place. We claim the original place first. Drawing some pixel arts. You mean that's your job? Why would you not be allowed to take a bathroom break? That's a different place. Let's call this assignee place. And then I guess we evaluate that first, then we claim, and then we say that this is occupied. And I can call this assign place expression. Could we using descripting variable names? Fog? I try. It's not always easy though, but yeah. Pattern match. Pattern. We pattern match place pattern. Yep. It is easy or it is not easy. I wanna complete it sooner, but I did make the mistake and it's not my job. I'm trying to learn pixel art. I see. Yeah, okay, yeah. When you're working on something which you are passionate about, you can forget about taking the bathroom breaks. But like you can take a bathroom break. Believe in yourself. You can stand up and go to the bathroom, and then you can continue your pixel arting. I'm pretty sure. But yeah, I do sometimes not go to the bathroom because I'm really like focused on doing something. I can see what you mean. You forget to do the bathroom breaks, you forget to eat because you are too focused. ID value type. This is evaluating the binding. In this case, we evaluate it and we create a new place, right? It's just place in it. Oh, this is not found. Yeah, this value is not found. Yeah. We just do place initialize state. State is going to be uninitialized, I suppose. We allow numbers as type variables. I want to make sure I'm not copying you again. I don't have it yet, but I'm assuming that you, like similarly to TypeScript, want to have like values as types, right? Where you have the type, which is like number 1, and then you can only have the value of number 1 when you have this type, right? Or you can have the type which is string hello, and then it is it can only hold that value, basically, that type. I don't have that yet, but I think I will. Yeah. I feel like no, that's different. You just think numbers are good descriptors sometimes. You mean like, what do you mean then? Good descriptors. I think my mind benefits from frequent breaks. Grinding for a long time, I can lose the forest, the trees. Hello, two-step. I mean, yeah. That's why I have chat open. So we do get distracted sometimes. But like, yeah. Or when I'm working, I'm also like watching somebody else's stream, which is what a lot of people doing. Watching my stream and like other streamers too. From 1 to. What does it mean though? What does it mean from 1 to? Good descriptor sometimes. Like this is the first argument and this is the second argument. From first type to second type. Just use numbers as identifiers. But why don't you call them from type 1 and type 2 then? Or from argument 1 to argument 2. Like, what's the reason? You can do that if you want to. Yeah, I'm not sure. I see the benefit here. Like like in general, the reason I'm not doing that, I guess, is because when I'm parsing the expression, which is like, I don't know, let's say let x be 1, right? What does this mean then? Like, what does it mean? Does it mean that I need to create a new integer with the value of 1 in this place, or am I looking for a variable of name 1, right? So I need to differentiate here. And I guess so, like, but that I need to do that because for me everything is an expression. I'm treating everything the same, I guess. But since your parser knows when it's parsing type of value, maybe because of that you can do it. I mean, for me it's not the parser that knows, but like the compiler that knows when I'm trying to compile a type expression. So I have like type expressions and I have value expressions, right? Yeah. But yeah, but like if I allow like variables with names which are integers for types, then not allowing that for values is weird, right? Because that makes the language not consistent. Like, well, I mean, yeah. Like I guess in a lot of languages, the types and values, they live in like completely separate namespaces. So it's not like that different, right? I mean, it's not that. Yeah, I guess it's just because I want to treat everything the same. I don't want to special case anything as much as I can. Alright, we initialize the uninitialized with the type being expression data type here. Okay, so now we have the temporary variable, temporary expression. We evaluate this to the value, and then I create place. We initialize the place with this value. There we go. When I dereference a reference, now I evaluate this to the reference. We do value expect reference. I did not make that, right? Let's create an expect reference. Expect reference is a thing which returns a place option, right? Because that's what a reference is, it's just a place. So if it is a reference to a place, then I return some place. Like the idea of types being values, seems like it will prevent some duplicate logic. Yeah, I feel like I feel like the way I'm like, yeah, I treat everything as values, right? Including generics, for example, right? Which does remove duplicate logic in a lot of places already. Because for me, constructing a generic type, because generics are literally just functions, also I'm removing duplication there. So constructing a generic type is literally just calling a function with the argument being the generic type. Right, and it also, because it's just a function, it can return anything. Generic type and generic function are not different. It's just that generic type is a function that returns a type, and generic function is a function that returns a function. You know, so like it's like I feel like I'm unifying a lot of things that are normally special cased. You know, if I can find like more things to unify, I would probably go for it too. One thing that I was thinking about is like treating patterns as values. I had some thoughts about that. Don't really remember where they went. But yeah. It's simple, and in my mind, less code is almost always better, or at least easier to understand and maintain. Yeah, I agree. I agree. So like I am saying that I'm not really going for a simple language, right? Is Zig like that as well? Types as values? Yeah, I think Zig is also like, yeah. Zig is also like that. Yeah, and Zig also is doing generics using compile time evaluation, so that's also similar to my language here. But yeah, I'm saying that I'm not going for a simple language because I want a lot of features. But the way a lot of features are being achieved is through combining a lot of simple features, right? So I don't have a feature which is called const generics, for example. Like Rust has a feature called const generics. I don't have that because like how is const generics different from type generics? You know, it's like literally the same thing. Why is it special cased? And like there is a lot of examples. I don't know, infiltrate in return position and like something like this. You know, infiltrate in return position in trait are like something, right? Rust RTIP TI. I don't know if what happens if I just search for this. Return position infiltrate in trace. That's what it's called. aka RPITIT. Like, why is this like a feature? Why is there a feature that's called return position infiltrate in traits? Like, why is it special case like this? I mean, I understand why, but you know, it's weird. That's why Rust is a complex language. You know, but I feel like if you design a language from scratch, maybe we can get rid of a lot of these things. Yeah, well, like one of the other things I think that already is simpler is like the macro system, right? We also treat like ASTs as values. Separating it makes it clear what happens at runtime and compile time, but I agree it's more complex. I mean, yeah, but like we still like try to do a lot of compile time evaluation, right? We do, since I was talking about the ASTs, like there are macros, right, which happen at compile time, and because like it is so special, like it needs to be like in a separate crate. I don't know, like there is a lot of annoying things, and it is just, I feel like, a lot simpler in what I'm going for, you know. You really looked at proc macros, Rust, which to in at Rust proc macros, which get to ingest the AST. It was far more complex than I thought it would be, and I went running back to declarative macros. Yeah, it's because they don't even ingest the AST. What they ingest is the tokens. The Rust macros, they work on tokens directly, so it doesn't even have to be the proper syntax. It just needs to be properly lexed so that it can be an input to your macro. Which leads to duplicating the work also. It's not only like more complex system, but it leads to less performance when compiling your project, because when compiling your project, you're going to be parsing the same code multiple times because of multiple procedural macros. Like when you're deriving multiple traits basically for your struct, each of those derivers is parsing your code from scratch. So yeah, I feel like that's bad. Okay, so we evaluate the state, we evaluate the reference, we get the reference back, and then I match that, and if it is not a reference, no, let's do this. I mean, yeah, sure, log error, span expected a reference. Expect a reference at a reference data span. There we go. This is a reference expression. Thank you for not renaming that. And then we just return here. We return error. Okay, and then if it is actually some place, then so now I am dereffing the place and I get the place back. Yeah. That's all. Oh yeah. Oh yeah. So if I'm dereferencing not a reference, this is not correct, right? I don't get the error. I instead get the new place. Actually, should I have a place which is like the error place? I should not have a place which is has the error. Yeah, I don't think so. But maybe I should have like like error place, like construct a new error place of type. Yeah, let's do this. Error place. This, and over here, this is going to be error place. Of expression data type, right? So the same stuff. So then error place is type into place. Function type is just going to be place in it state. Like I'm not sure if this should be uninitialized. Maybe I initialize it with the value of error. We'll see. Type. Okay, so now when I have the expression field, place expression, we need to evaluate this. This object. I mean, I think technically place expression. This is expression field. Like this should be place expression field first, right? And expression binding. No, expression binding is not there. This should be place expression field, right? This should be place expression field. But in the place expression field, the object itself can be a place, I think, right? But we will always claim. I mean, yeah, because. Yeah, let's make this a place. It makes sense. Is this game in OCaml? No, the game is not in OCaml. The game that I'm making is written in Rust. This story here is OCaml. I'm making the language. The language is written in OCaml. But the game is written in Rust. Hello. Alright, and then I need to copy paste. Can I like make this not copy pasteable? There's like this is so annoying. Alright, let's copy paste. Let's copy paste. Wait, what? Yeah, let's copy paste this to that. There we go. Are you going to rewrite Linksider in cast? Yeah, no, I don't think so. Maybe Linksider 2 though can be written in cast. Although I don't know. I mean, so like Linksider is weird because I mean it's not weird, but what I'm trying to say is I never tried to go for making a puzzle game. The reason the game I made a puzzle game is because we were participating in a lot of game jams, and that turned out to be a good game, right? But yeah, like ideally, I would want to find something that is more replayable, I guess, right? is my main problem with puzzle games is that they are not replayable, right? You just solve the puzzles once and that's it. So, like, I'm making the ideal programming language here, right? And if we talk about the ideal game, then, I don't know. What would I like to create? Some survival game, some sort. But yeah, I don't know. But maybe we'll be locked to puzzle games because of Linksider. It's a good game still. Will take a while to finish, but yeah, but you still finished it once, right? At that point, people feel like replaying. I don't know. Do you replay Baba Is You, for example? Do people replay Baba Is You? I feel like there is no reason to do that. Even although like you forget the puzzles, it still is. There are puzzle games you replay. I don't know. I mean, I guess I don't really like play puzzle games. Maybe that's the biggest issue. All right. Anyway, so we have place expression. Here this should print place expression object. It's just printing. Wait, it's not a place. Place expression field object is place expression, not place. Okay, so now when we try to evaluate place expression field, we evaluate place object. So this is my object place, right? But I guess for now we will just claim it here. I'll need to see how to do it without claiming the value from the place. Tuple. So we get the field and we return the field place here. There you go. And in this case, field doesn't exist. In this case, we return error place of type expression data type. Yeah. No, not a no. Wait. Yes. Yes. Yes, that's correct. If it's a target, we do the same. If it's name of a target, then it is place in it with this value. Okay, and if it's an error, then the object is error. We just return error place immediately here, and this does not have fields. Also do the same. And this should not be value print. Yeah, no, hold on. Value, yeah. So this should be value a print. Value doesn't have fields. Although they should be about the type, I guess, maybe. Whatever. Let's go next. So now we have expression, and we have two new expressions: expression reference and expression read place. So let's start with the. I mean, both of them are really easy. If we have an expression reference to a place, then we just we need to evaluate the place, right? So we say evaluate place, like this, and then we just return a value reference to that place. There you go. That's easy. And then if we have a expression read place, actually, should this be read place? This should be claim place. I should rename it because that's the naming that we use, right? So we do the same, but we say that we just claim the place. Place claim. That's all. So we evaluate the place and then we claim the value from here. Let's call expression read place and replace that with expression claim place. Maybe just expression claim. That's general what claiming means, I guess. We're claiming places. Nothing else to claim. Okay, now we have expression tuple. We are initializing the new tuple, so we initialize every field here, right? So every yes, we say that place is place initialize new one with this value. Okay, and we have a variant that's the same. We have place, we have value option map place in it. Okay, next, if I'm assigning this just needs a span, right? Span in this case it's the value expression and value. Okay, and the value it must be the place, right? Value is value expression data span. Value is value expression. So this over here is a value, right? But this should be a val place instead, which means my expression assign should also have the value, which is place expression. When I print value, this is going to be print place expression value. All right, what is this? What is this now? This is a module. Place. This is locals. Interpreter local. We have locals. Module. We have all the locals. And they should be the same references even. I think these, in this case, we actually use the same place. Okay. If I use dot star, I need to add the local for every field. Fields have places. And we actually use the same places. Add local, but this is value. I feel like I need to add a local using existing place. Like, think about this piece of code, right? Let's say that I have something like this. Let foo be dot x is equal to 1 to 3. I feel this feature is present in Jai, if I remember correctly, right? So what we want to be able to do is use foo.x, right? And then we say x is equal to 1 to like 4, 5, 6. This actually changes the field in this thing. Right? Which means that when we use an expression, we still use the original place. Which means that reference to x and reference to foo.x is the same thing. It can be nice. I don't know like how much it is used in practice in Jai. I don't remember any other languages having this feature. But yeah, basically we have the use expression. You normally just use it to like input something from the prelude, but like under the hood it's the same stuff. So yeah. Going to add local using a place. I guess I do add locals because of that. So this should not be removed. But like this one takes multiple and this one say takes singular. When we do singular, we do a value. When we do multiples, we do locals. Okay. Yeah, let's see here. So we do add locals. Scope locals. Wait, what is locals? What is locals? Locals T. Interpret locals. Just by symbol. Maybe I should have the... Let's call it at local... I don't know. Let's say add local existing place, right? This is going to be field place then. And then I broke my formatting. What did I... Hello? What did I break? Oh, camel? Excuse me? What did I do? I didn't close this this one. Is it because of that? Yes. Field span. This is not a function. It cannot be applied. What was written here previously? Let me try Control Z-ing. Yeah, at local existing place. I just give it the field place here, right? So that's the difference. Add local existing place is going to be similar to add local, but using instead of values, it's going to use the place, right? And that's going to add locals using by add locals by symbol map singleton symbol place. Equal unbound record. Am I adding places reference to speed up day 4? Well, it is to speed up day 4, but also because that's how I want the final language to be anyway, right? I want it to be a Rust-like language in terms of move semantics and references and stuff like that. Because it's important for low-level coding. I'm imagining that like Zig also has the like every low-level language has the something like which is the place expressions and stuff, right? What do they call them in Zig? Do they also call them places? Or do they call them L values like C? Please. He calls them pointers, sometimes references. Well, I mean reference like I guess like like even in Rust, you don't really like you don't really talk about places when you're writing code because you only are working with references and values, right? But places is like the internal thing. You cannot get place as value basically normally. Place as value is just a reference, right? But the reference is the thing that's pointing into a place, right? That's what I point the reference, right? The reference is referencing the place. It's not referencing the value, is the thing, right? So I would expect them internally to call them not references and not pointers, but still places or something similar, right? Because in order to construct a reference, you say like x. I think in Zig it's like dot ampersand maybe, right? Is that how you do it? To take the reference of x to x, or is it still a reference to x? I don't remember. So yeah, in this case, what is x, right? This is not an expression. This is a place expression. And the difference is that we don't actually need to know the value of x to get the reference to it. Okay, we have place, and we have type field. Type is place type. Label is label create definition. To take the references prefix, but to dereference is postfix. Yeah, I see. Yeah. Is this in this case is my label a reference or a definition? I think it's a reference. Create reference. Span a symbol name. Okay. I think I'm almost done with the interpreter, and then there's a little bit of stuff in the compiler, and then it will be working, I think. So what is this? So this is the match expression. We're doing the pattern matching of the value. So yeah, in this case, when I'm doing the pattern matching, that's another thing. When I'm doing the pattern matching, the value that we're pattern matching against is not an expression, it's a place expression. Yep. Because depending on the patterns, we might actually never move the value out of the thing that we're matching. Expression value. So this is print place expression. There's probably like more things like that. So we evaluate place. We evaluate the place, and that's going to be place. Value is place, expression, place, expression. Place. Pattern match at this span. Span is going to be place, expression, span. Okay, I think that's all. And then when we have unwindable, this is the same stuff. We're doing pattern match into the token pattern. Token. A token is a value. So I actually create a new place here. Span is token pattern data span. And we're going to do place initialize with the value of token. Okay, and then a little bit of the natives. Let's see. Also, like speaking about the syntax, I'm not sure what I'm doing with the syntax yet. How was I doing the syntax before? I'm pretty sure I was still using the prefix references, just like Zig and Rust and C. But the dereferencing being postfix is good. I like that from Zig. What was I doing previously? I don't remember. Let me see. Let's go to here, cargo run. Let's see. So we have like reference to 1. This is reference to an integer, right? And then we do reference to 1. Is it? I think it's like dot caret actually. No, no. Dot star. No. Is it just caret? It is just caret. Okay, yeah. It is postfix, but it's a caret. Because it's an arrow pointing up. That's why it's that. I feel I think I remember some other language doing that syntax for dereferencing. Hmm. Like I stole the idea from somewhere, but I don't remember where. Okay, we have a module string at. String at. S is string. String S is string. No, it's a value triple field. Yeah, okay. So we just have S place claim. I need to like. Can I do command claim here? Yeah, I guess I can. And when I claim, I need to give it the span. Color. I mean Spanish color, right? Okay, and then over here, so like I need to do it for every like argument unpacking. Then so we do index place common claim Spanish color. Just copy paste this because I will need to do that in a bunch of places like here and here. Maybe I could do it somehow without duplicating this stuff. But here I'm calling using f value. What is f? F value. F value. Common call f value. Wait, but this is my function, right? This is my function. Okay, let function be f place and then this. So I want to only claim it once, right? Not multiple times. But we expect it to be a function is the thing, right? Yeah, so we just call the function f. Sense. Okay, next this and that should be also that. And that. And that. Alright, finally, we are done with the interpreter and we need to go into the compiler. So the only thing about the compiler is just I need to initialize the type inference properly here for the new expressions, and we no longer have the expression binding. Right? We no longer have the expression binding, but I do have now the expression reference. Expression reference of a place expression, right? So in this case, the type is going to be type inferred is going to be type reference of place data type, right? And then we have expression claim. Place, this is going to just be place type, right? So that's the type. This data type. All right. Now we have expression variant. Uninitialized. Why is this uninitialized? It's because OCaml language server, like, it's so bad. I told it to rename the thing, but then it did not rename what I wanted to rename, and then it renamed the things that did not need to be renamed. So bad. Like, it's like this over here. Like, why? I never did that. I never did this change. This is the OCaml LSP doing this. Revert selected ranges. And over here too. All right, we don't have the expression field anymore. But we will have init place expression, right? Which is going to be evaluated expressions, expression list, span state t, expression shape t, place expression place t function val expressions span state shape is into match shape with that. Okay, let's see. So first of all, I want expression. This is not the correct go-to. This is not the correct go-to. Hello? Module place is struct. Type T is expression place. Place, I call it place expression. Yeah, that makes sense. Print is print place expression. Wait, there is no thing like that? Print place expression. Okay, so this is place expression field. Expression shape. This also should be expression place shape t, so we need to do that too. A module shape is struct. Type t is place expression shape. Print is print place expression shape. Okay. So what do we do here, right? We have pattern match is not exhaustive. Right, let's see what's happening here. So I have a place expression field. What are we doing here? Object. This. You tried a little bit of Gleam. LSP is not super complete, but it is better than OCaml's. And less match nesting everywhere because I've used which resembles do notation. Yeah. Yeah. Have you tried F sharp? Also. No? I heard good things about F sharp, but I did not try it myself. It's another OCaml-like, I guess, language. but I would expect better support of the editor for it. This is the type, right? This is type. Override shape. Wait, what? Override shape? Oh, that's because of instantiating generics. Yeah, never mind. We'll just do try here. This, and this is type. And then after all of that, we try this. Shape, data type, ascription, evaluated expression, while initializing, place expression. Gleam doesn't feel like a camel because function call is farg, is not farg. Yeah, I feel like there's just syntactical difference though. So I don't really, I don't know, I don't feel the difference anymore. Really. Expression has type unit. This is not a function. It cannot be applied. What did I do here? Once inferred, we do this. Oh, it's because over here we need just semicolon. Yes, that makes sense. And this is a returning type. Okay, there we go. Okay, so like this logic is still the same. I'm not changing it. The types of like the fields is all the same. Yes. Okay, then what are the other place expressions that we have? We have place expression binding. In this case, if we have a binding, then the type of this expression is binding type. That's really easy. And then we have a place expression. Place expression. Place expression. What am I looking for? Place expression, dref and temp. Dref, the reference. In this case, so this reference, yeah, so if we are trying to dereference the reference, right, it means that so I like our type, like, you know, like value type is we create a new not inferred in this span type, right? We will return that, but I will say that reference type we expect that to be inferred as we expect that to be inferred as a reference to value type, right? That's what we do. That's all that I need to do here. And then we have a place expression, temporary expression. Then our type is the same as expression data type. Okay, so that is done. This is tref. Next. Next. If assignee expression binding doesn't exist anymore, we instead have assignee expression place, right? And in this case, we just say that place data type. That's it. That's really easy. Is it done then? Assignee binding, inject assignee bindings. Now we have assign a place. Yeah, if it's like an existing place, then we just don't do any. We only do for the lets. Yes, that's right. Okay, next expression assign. What is this? This is the core. No. Yes, this is the core syntax. So now we have the core syntax assigning. Okay. So expression assign has the value, and value is now not expression, it is a place expression, which also means that we have a new compiled kind, which is a place expression, which is a expression place the compiled kind, right? Like this. Okay, we have a place expression. Init error. If we have a place expression, then we need to have a place expression. Oh, yes, we need a new type of place expression, which is an error, right? Init place expression, spend state. And I do not have that. Let's open types. This is going to be a huge commit. Place expression shape is, we need a new one, which is place expression error. And I'm printing that. Place expression error. We just print the error. In the interpreter, if I have place expression error, we just return error place of expression data type. Okay. Now we're back to the compiler. When I am initializing place expression error. Wait, what's the type of the errors? Normally that I do here. Just new not inferred type. Yeah, that makes sense. All right, update data. If I have a place expression, then we have a compiled with data is f compiled data. If we have this place expression compiled dot data. If we have a print, this is printing the kind, place expression, fprintf, fmt, place expression. Core syntax. Okay, core syntax has like 1,000 errors now. Yes. Okay, so yeah, it's because now we have a new kind of expression. So when I'm trying to compile the syntax and in this case like function application, and it is and I'm trying to have the function application as a place expression, it means that we're creating a new temporary variable, right? So we need to have if this is place expression, then using Gleam for Advent of Code this year. It's been nice to use a language that is very simple. Yeah, maybe, I don't know. I don't know. Like, it's nice to use a simple language when you're trying to solve a simple tasks. That's what I think, I guess. And Advent of Code is simple, so like, it is nice when you have a simple language, because like, if you're learning the language for the Advent of Code, because that's what you're doing probably, right? It makes your experience easier, right? But when you're trying to write a complex application in a simple language, that's when I think simple language is a bad thing. Okay, I need to like do something here. File. Yeah, like I need to do something here that this is going to be just temporary place, you know. Let's create this helper function, temporary temp place. Maybe I will rename it to something. Temporary place module C AST compile temporary place. That's what I want. So we will have maybe we can move it somewhere else. Compiler dot temporary place. Like I can move that logic there. What do we have here? Oh shit, but we have evaluate and stuff, temporary place. Init expression. Yeah, I think I can do that here. Compiler, right? So we basically say that temporary. Let's just call it temporary. Temporary expression. Temporary expression, sure. Good enough name, right? Temporary expression. We have a module C, which is the compiler, and we have AST, and we return expression place T, right? Because that's what it is. Which means that we're going to compile expression first. So this is the expression, but then we convert it into a temporary. Into place expression temporary expression into init place expression AST span C state. That's what I want. Yeah, I guess like a very small simple function like this is what I need. And I will use that function in a lot of places. Over here we have instantiating the generics. Instantiating the generics are always going to be instantiating two values, I'm assuming, right? So if we see a place expression here, then I should just compiler temporary expression module C AST. Let's actually copy this, because I will need to do that in a bunch of places, I think. Okay, next, if I have a scope, scope, for scopes, it's actually, if I have a place expression, then I just compile. I do enter the scope here, I guess. And then I compile place expression here directly. Place expression. It does not introduce the scope expression though, like this, so it may be bad. So like if I have code like this, a reference to a parenthesis, x, right? Or a reference to let x be 1 and x, right? Inside of the if I do parentheses here, then it means that there is also always a value, right? Or not? Or do I try to allow this to get the reference to the original X and not to the temporary, which is like copied from the thing. But in case of that, it is actually interesting. I think for now, for safety though, before I'm just going to do the same as I was doing before. It's going to be a temporary after all. Temporary AST module C. And this is compiler. I think that's correct. When we have a placeholder reference to not inferred thing, yeah, that is definitely like a value. So we just do that. If we have function type cannot be expression. Function type cannot be a place expression. The function itself is a temporary, I guess. So we can take a reference to the function. If we have a generic, that's going to be same. If we have a unit reference to unit, that's a temporary too. It's a temporary value unit which we take the reference to. Yeah, makes sense. If we have a type is an expression which evaluates to a type. So we have expression constant. So if I have a place expression, I will do a reference to a type. I mean, it's kind of this, but then I have already done a little bit of work here, which is weird. Initialize expression and stuff. So I kind of want this to be moved here and here. But this makes it duplicated work. So let's make this a function then. Yes, making it a function makes sense. So in this case, I just call it, and in this case, we call it here. Yeah. Okay. If I have a boolean, then that's just a value. Yep. And this is like here. Like that. Color temporal expression module C, because this should be C. If we have a type expression, that's the same. That's the same as the type which is singular. So we do this An import. Should I be able to take a reference? The import. No, I think not. I think if it's a place expression, then we just compile it as a temporary. If we have a const let, what is the problem here? Because I'm assigning this to this value, which is a constant, which should basically be the temporary, right? Yeah, we should like have temporary expression. Okay, sure. Let const be this in. I'm just going to say temporary const init place expression. Expression data span c state const. We create a constant, put it into a temporary place, and then perform the assignment. Okay. Yeah. The const. If I have a const, yes, sure. Although actually in this case, I feel like it should be more like it should not be a place expression. Whatever, let's do that. If I have a native, natives will never give me places, so they're always giving me values, right? At least for now. Over here I do the evaluation though of the native. So it's a little weird here. You know what? Let's do an error here. Native place expression, not place expression. If I have a module, let's do the same. If I see a dot, so a dot actually must be a place expression here. And if it is an expression, yes. So like we need to actually have the opposite one here, because if it's an expression, then I need to like immediately read this place expression, right? Because that is a place one. So we just say that I am compiling this. Right? So let's see. I'm going to compile expression, right? That's going to, and I'm going to compile this as a place expression, right? So it's going to be place, and then I'm going to say expression claim place initialize expression span state. Right? And then if we have a place expression, let's see. Compiler scope, initialize expression, expression binding. What is this? And also we are going to return a place expression field, right? So object, what is object? Now object, in this case, must be also a place expression, right? Object expression. So I don't evaluate this because that's a place. But so we will need to evaluate place here, right? Evaluate place, and then we say eval object, cast interpreter. I will need to like claim this thing in my span, and that is my object. And then I can do that stuff. Now object expression, this has been evaluated. Now I can evaluate place expressions too. It's wrong, which means that in this case, okay, maybe I evaluate the expression after all and not this. But the expression is going to be expression claim object into initialize expression span, right? I don't have span. Function applied to this. Oh yeah, because it's not named argument. Yes, we do this, and then it's a expression binding. Yeah, I see. So this is going to be place expression binding. Makes sense? Wait, place expression binding, yes. That exists. That exists. There is no constructor of type expression shape because it thinks that it's an expression shape. Why does it think? Oh, because it's an initialize place expression. That's why. And over here we also initialize place expression. Okay, I think that's the dot syntax should be done. Now we go tuple field. Tuple field, if we want to have the place expression, tuple field, place expression. No, this should never even happen, right? This should never even happen. Fail with unreachable. Do I even have an unreachable? I have unreachable literally, right? Unreachable. Tuple field. Expression binding value is expression binding. If it's none, then it's a place expression binding. And then we say expression claim place initialize expression span. Boom, 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 boom. All right, a couple more errors, I think. If we have a type expression here, that's the same stuff. That is the same stuff. We say that place is this. Initialize place expression span. And then expression is expression claim place. Like so. So this place expression binding. Okay. Comma impl. To do comma assignee. Yeah. So if I have an assignee. Wait, what? No, not assignee. If I have a comma as a place, it does not exist. No. Comma implementation. We have the tuples here. I feel like I need to just do it originally, you know? Over here we say that place expression unreachable, comma, checked earlier. I don't know, let's say that. So it's checked earlier because I need to, like, if kind is a place expression, then comma is just a temporary, right? So compiler temp expression module C AST. Otherwise I return all of that in any other case, you know? Yeah. So now if I have the use syntax, use used expression shape. Oh my god, used expression is an expression. If I used a binding, because this is an expression. Wait, what? Is it literally an expression? It means that the use should actually be a place expression, right? Yeah, this should be a place expression. And then we have a place expression binding, place expression this. Yeah, that works. And we have const let. Expression. But now expression is a placed expression. So when I do a const let, so value const let, where is this even being used? In these two places, when I'm doing like literally the const, and then when I'm doing the use in two places. I guess I can just give it the place expression to the right already. Right? Value expression. Nah, that's weird. So I think used expression should be claimed, right? So we say used expression is expression claim used expression initialized expression used expression data span state, like so. Okay. All right. A little bit more red in this file. If I have an if, ifs are always place expression. So if I have a place expression here, then why am I doing that here? This should be done in this place, right? And then if I have place expression, then we say compiler temporary expression module C AST, right? Like so. If I have the impulse syntax, then impulse syntax sure, we'll make it a temporary, although that's weird. If we have a match expression, match must be expression. Let's do this on the, like, over here though. Let's do that. here, and let's do this on the outside. So we do match that, right? That's what I want to do. And BAST span. Match value. What's value? Value is compile expression. Yeah, so now I'm compiling the place expression because that's my values. Okay, nice. Is this the last thing? So now that I have a binding, if I want an expression, then we claim. Okay, let's see. So let place is place expression binding, like so, and then we return. If we want a place expression, then we return the place, and if we want an expression, then we say expression claim. Place, initialize expression, span state, and this should be initialize place expression. Okay. Is this okay? One more variant impl. When I have a variant impl, it actually well, in case of the in case of a place expression here, we are going to make a temporary compiler, temporary module cast, right? Expression variant. Okay, is it compiled? No, not, because over here, what is this? This is me initializing the compiler itself. I'm doing the fake span interpreter. I'm injecting the binding with the name because I have the interpreter locals. Compile 4. We have compile 4. Compile for this interpreter. Yeah, okay. Which means that we inject the binding, so we have local place type here. That's actually easier. Okay, now when I'm compiling an expression, this is compiling a simple token. A simple token. When a simple token is an identifier, when we create a place expression, but it means that, yeah. Okay, hold on. If we have a place expression, then we're going to match a token shape with. So place expression, which is a single token, is just an identifier, in which case we are returning the expression binding, place expression binding, and we initialize the place expression here, right? In any other case, place expression, it's going to be a temporary, right? So we say compile state kind ast, but we're going to compile state expression ast, and we're going to create a temporary place expression temporary. This into place expression span state. What are the other things? Like, because like strings are going to be temporary strings, this is going to be temporary number. Yeah, that makes sense. And now if this is an identifier here, in this case, what I want is, I want to say expression claim, compiling place expression ast, right? this. So in this case, we're going to create the binding using this branch, and then I'm going to claim that. Okay. If I have an assignee, then it's going to be an assignee place. An assignee place, compile, state, place expression ast. Just use the existing implementation. Yep. If we have over here a value, yeah, because this is a value tuple field, which have place, which should be place in it, with all of these things, right? Okay, and then over here, what is that? Interpreter with standard library. This is where we initialize the thing having the standard library. Okay. So standard library is a place initialize standard library. There you go. We put standard library in its place, right? Okay. Now there is just a little bit for the language server to work, and we're almost there. The transpiler, I'm going to comment that. I'm going to comment that. And I'm going to say types, expression reference, fail, lock, expression, claim is also fail, right? And then we have, I guess, some more types. Types, assigning, binding, to do support mutation. Yeah, this is so this places now. That's mutation, and then singlet, transpile expression value. Value is a place expression in this case. Can I just remove the cast transpiler temporarily or something? Fail with block. I don't want to look at this right now. Let's just look at the value ref. Okay. Is that all? All right. I think now just the LSP stuff is missing. So if we have expression ref ref to the reference, which is a place expression, then we should handle place expression ref, right? And then we have expression claim place. I mean, this is reference to a place. It should be called place. We do handle place expression place. If I have now the place expression here, I'm going to match filed shape with some other things. We also have like the expression field here, which is no longer expression. It is instead over here a place expression, right? And object is also a place expression now. Yeah, we have a place expression binding. We don't do that anything then. If we have place expression temporary expression, then we handle expression. If we have a place expression, the last one, There's also place expression error, in which case I don't do anything. The deref. Place expression, deref. The reference expression, in this case, we also handle expression ref. Okay. If I assign, then the place is a place expression. My mic is making funny noises. Yeah, it happens sometimes. I'm sorry about that. If I have expression match, value is a place expression now. If I do assign, it will have assign a place, then we do handle place expression place. Right. Okay, is that all? Processing of the LSP. Okay, let's see. So we have roots. Because tuple get named, we have a place and I want to claim it. Claim that. Span. Do I have span here? I don't have span here even. Span. Span. Take LSP. Alright. Release value. Yeah, this over here is going to be filled place into interpreter claim span is fake LSP like that. Right, a couple more things when I'm covering things now. For the LSP, we don't have expression binding and we don't have expression field. These things are variant, are place expressions. Okay, so we say let's rename hover info rename option is match compiled shape with these, right? And then I return this type. Okay, so these two are place expressions, and we have a place expression error, and then we return none. Is that what I do? Well, I mean, we do in other cases, right? Binding and field. This is for renaming. Place expression deref none. I guess I will actually do the underscore here. Alright. Assignee, if I have assignee, this is hovering specifically, so we don't have the binding. So this is always none. Actually, for the assignee now, rename is none. Okay. What about this here? Get tuple. Place. So there is no place expressions which are tuples, which means that I always return none here. Okay. LSP completion. If we have types T reference, that's just a type. Types uninitialized. Hello. That's a variant. Inlay hints. If I have inlay hints, that's if I have an inlay hint for a place expression, I don't think we need to do any. Okay, it is compiling. Okay, if it's compiling, does it work? Do you guys think it's going to work first try? Well, no, we cannot do that. I need to implement the syntax first, and to do the core syntax. We need to do two core syntaxes. Which is a reference and dereference, right? Yeah, let's do this. Ref. 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 Let. It's a reference to place, right? So it's children equal unwrap single unnamed. Okay, and then we match. So if the reference expression, or if it's an expression, reference is an expression, right? Expression reference to place, and place is compile place expression place. There we go. Wait, place is AST child. AST child expect AST. There we go. Do this. Yes. So reference expression ref must be expression. What if it is a place expression though? If it's place expression, then we return compiler temporary expression module C AST, right? Now what I do? So we have reference and we have deref. Deref is going to be that's a yeah, now deref is a place expression. Otherwise, if it's an expression, then we claim the derefing. So we compile expression. ST, right? And we initialize expression. No, yeah, we compile place expression and do that. Makes sense. We just do claiming here. But still compile it like that. And then if we have a place expression, in this case, we just do place expression deref of C compile expression reference, because this is not a replace, this is a reference, right? That's what we are dereferencing. Init place expression span C state. Okay, I think that's all. I'm not sure though, and I mean, one small thing, but now not in OCaml, but actually just define the syntax for it. Define the syntax for it. What should be the priority of the syntax? But the syntax is going to be this: syntax reference something wrap never is. Is the reference even associative operator? Should I be able to do a reference to reference? I think so, right? It is a left. It is no, references are right associative actually, right? But dereferencing is left associative. So we take a reference to a value like this. So and then deref is we will use the caret symbol, and this one is left associative. But what the priority is? The priority should be like higher than the function applications here for sure. Should be higher than these. What about the generics? I feel like it's lower than the generics. So is it lower than the variant? I think it's this one is weird a little bit. It's like either 63 or 61, I think. So like should I be able to write, you know, like some reference to X, or do I require parentheses here? And if I and should I be able to write a reference to some X like that? I feel like the first one with reference to X being in parentheses here makes more sense to me, which means that Wait, no. If I think some reference to x makes sense, but reference to some x, this is a little weird, right? Reference to none. I mean, reference to none is this, right? So if I want a reference to none, then like I would need parentheses if I allow this syntax. I don't know. I mean, both of them make sense a little bit. Let's try 61. Wait, but the dereferencing should have the same priority, right? As the referencing. What if I write code a reference x and then the reference? So right now this is left associative. The dereference is left associative, so it allows this. So this is going to be parsed like that. Reference to x and then dereference it immediately. Wait, no, it's not. Because this one is right associative. It's actually like weird right now. I feel like they should have different priorities. What about Rust? I mean, but in Rust it is all on the one side. Yeah, I guess like since they are all on one side. What about Zig? If you say like reference like a dot star, right? That's how you do it. What would that mean? It would probably mean reference to like it's going to return the same original pointer, right? So it's parsing like that. Maybe I should fix this priorities when I actually see this being an issue. Let's just do that. All right, let's test it. It's going to work first try, right? First try. Let's see. Cast. Is the standard library parsed successfully? Okay, let's see. Reference to 1. Must implement the rule before using it, because this should be core. That's the core syntax. Reference to 1. There is no core syntax ref. I forgot to edit, I think. Ref, deref. Let's try one more time. Reference to 1. Nice. It's a reference to this. Because this is a place. I feel like I should put this differently in printing. Printing value ref. I want to print this should be place print place ref place, I think. Let's see, this probably is going to be better. So when I say reference to 1, it's a reference to occupied place with this index, right? I don't know like what else would I be printing here, but yeah, I don't think we need to print the actual value, right? Because it's a pointer. Okay. So then let's say that let x be 1, right? And then let's say the reference to x is this. Okay, let's say let's say this. Let's say pointer is reference to x, right? So x is 1 and pointer is reference to this thing. Then let's say that x is equal to 2. And then let's see what pointer is. Pointer is still the same, obviously. X is now 2. But if we try to dereference the pointer like this, then it's going to be 2, right? So I have, yeah, I think that works. I think this means that it works. What else should I test? What else should I test? I can say that let foo be like a tuple where field x is like 1, right? Which is similar. So we can take a reference to foo.x, right? And we can do like what do I do? Foo dot x is I don't know. I guess we just say x is reference to foo.x, right? And then we say foo.x is like to do assign to field. Okay, have to do assign to field. Oh wait, right. I could not do that before at all, but now I should be able to do that because this is places. I can actually implement this now. Okay, but I can still like mutate the fields now by just saying like, yeah, I can just say, you know, foo.x dereferenced is equal to 2, right? I can do that. No, reference must be expression. Wait, what is reference must be expression? Ref must be expression. I think like deref must be expression, right? But it is assign. Wait, like in this case, it is assignee, right? So we say that if I am trying to do the assignee here, then it should be assignee place, compile place expression is the init assignee. Yes. That will work. Let's also do, what was it like to do assign to field? That's just the core syntax. Yeah, so if we have like assignee, and this is the dot syntax, then this is literally the same as I just did, right? Because I'm just assigning to place. Because the dot is the place expression. Is the OCaml compiler being stupid again? I think the OCaml compiler is being stupid again. I need to say that this returns A, because OCaml cannot infer this. Okay. Although, I mean, we'll see if I will be able to infer this when I have generic GADTs. I mean, yeah. Alright, let's try again. So I should be able to say foo is this, and then I say foo x is equal to 2. Type check failed. Reference is not equal to int32. Expected a reference. Okay. Expected a reference on 1.1.2.1.8. I should create an example, right? I guess. Let's see. Examples, refs. Let's do that. Examples refs. Not kx, ks. Use std prelude. Okay, so say foo is x is 1, 2, 3, right? And then I should be able to say that foo.x is 1. I should say, oh wait, no. This makes sense. This actually makes sense, right? Because like foo.x is not a reference. This actually works. It should like be, if I say take a reference here, then this should work, right? Because a reference to foo.x is a reference which I can dereference. But it still type checks. Type check failure because reference is not the integer, which is weird, right? Let's see. Foo.x is 1. reference foo dot x dereferenced is 2. Let x be referenced to foo x. X dereference is 3. dbg print foo, right? I don't know. Cast examples ref. Okay, wait, hold on. This works. Wait, what doesn't work? What just did not work? This? Oh, I see why though. I see why it did not work. It's because yeah, because I'm breaking my type checking after errors. So like we cannot trust the errors that happen after I already had the error before. I need to fix it. But yeah. But I think this works. Yes. We have references now. And stuff. This is going to be a huge commit. Can I like show git diff stat? All right, I just did 1,000 lines of code. Do we look over it? Nope. References and place expressions. We just commit. But what we can do now is something like this. Let's go to the standard library, to the collections, right? Let's take a look at the list. So now pushback can be a thing which takes a list by reference, right? Wait, I need to create a type which is a type expression reference, because this this is not going to work. Let's do this cast. So if I say like type reference to int32, right, then that does not work, right? Because it thinks that this is an expression. So I'm trying to actually take a reference to the type as a value, which is weird, of course. Let's see, core syntax reference. It does make sense to do that for dereferencing, but for referencing, if this is a type expression, then it should be type expression reference. Type expression reference. Compile a type expression place. Like, it's not a really place then, right? This is just the inner type. Initialize type expression, span C state. Yeah, so I need to create a new thing which is type expression. Type expression reference of type expression. Type expression reference. Reference. Evaluate type. If the type expression is expression reference inner, then we say that it's inferred. Well, let's do this. That inner is evaluate type state inner, and we say infer span type reference inner, right? Okay. It's easy. Compiler init, if we have type expression, a reference, inner. I guess I don't do anything here. There are already type expressions inside there. Or syntax, type expression ref. Compile type expression. Expression should not be a constructor. The switch type is unit. Yeah, we do function into this. Right? If this is the LSP stuff again. If we have type expression reference inner, then we need to handle type expression inner. Okay, let's see here, cast. So so I say type reference in 32. Could not find in 32 in scope std in 32. Type check failed. Is it because I need parentheses here? Yes, it actually is because I need parentheses here. But yeah, if I say something like let x is a reference to std in 32 is a reference to 1 to 3, then that's going to work, right? Yeah. Okay. Reference type expression. Bum, 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 bum. So now I should be able to do that, I think, in the collections lists. Right? So yeah, right now we're creating the list, and then we are adding the list, which creates a new list, and we reassign the thing, right? But now what I want to do is I want to just add to the existing list, right? What is it called that? I renamed it to be pushback, I think. Just pushback. Cast examples lists. Right. So right now, this is not printing anything because pushback still returns the new list, right? So now we go to the standard collections. Pushback will take a reference, and we will say that basically a dereferenced is equal to trip merge yeah, like I guess in this case I just reference. So right now taking by value and by reference is not really like much difference, except for the fact that this way I am allowing it to be modified in place, right? I guess I can do that for now, or can I not? See, there's a small stack trace. Type check failed. Empty is not equal to that. Yes, that's right, because this is now returning unit, and this can do a semicolon, right? Because this is an effectful function now, which has the effect of mutation. Okay, what else? Well, initializing. Type check failed. Type check failed where, though? In example lists. List pushback. Oh, yeah. Now this needs to be a reference, right? There you go. Nice. This works. This works. Can I restart cast language server? So that it can actually tell me this thing. So like if I say this, it's going to say that type check failed. The errors are really bad right now for my type checking. But the only reason it's bad... Well, first of all, for the not inferred things, I am printing the spans. I think I should remove that. When underscore print variable this over here. Inference var print this over here. I guess I don't need to print the IDs here anymore. I'm just going to comment this and just do an underscore instead. Right. So if I go here, then it's just going to say, yeah, just underscore here. So a lot smaller. But now the problem is that we have the unnamed types. Yeah. So I need to introduce named types maybe somewhat soon. Make this less annoying. And that stuff works. So let's maybe go back to the advent of code, day 4, and is it day 4? No, it's day 3, right? Day 3 was using it. Like it's lists. Also, like, shouldn't list at index return the reference here, by the way, right? That's what it should do, I think. Which means that I don't need to do the set at. Instead, we're doing at dereference that, and just do that. Yeah, that makes sense. Which also means that update is not really necessary as a function anymore. Having all of these take reference makes sense. Let's just try do like the final API maybe here. And when we iterate giving the reference to T, right? Something like that. Let's go back to a trip. Trip has value, which is T. Create singleton length. So over here we take a reference to trip. When we merge, I merge two references. This is going to construct a new trip though, right? Update root data T. Yeah, so in this case, yeah, also like matching left and right, right? This is going to it's going to take things like I need to like in the pattern matching to match by reference like in Rust in this case. Like yeah. Because left is a reference now. I mean, yeah. And these are also references. Yeah, hold on. Is it over here left and right? Should these be references to existing trips? Then, or should this be by value? I don't know. You know what? I retreat. We don't use references here. We take these by ownership in the future. But when I take in length, this is where we can do reference. And in this case, so now we match the V dereferenced because we don't have the match ergonomics yet, I guess. Now split at is also going to take by value, sure. If index is length V, well, then we return that. V. Check fail. This is not reference. If index, which is an integer, is equal to length V. I don't need parentheses here, right? That's not the problem. The problem is that I guess whatever return here, left, is that merge. Should be fine. Wait, there is no references left, right? Is there maybe length over here? We have length v left plus 1. That's probably the problem. Over here I say length v right plus 1. And over here, yeah, everywhere, every time I do length. And over here, v left. So now enter list. Yeah, so length is like that. Trip at. Yeah, so trip at is a function that should return reference to t now, right? Because we can return a reference to the value of this node, right? Reference to do panic out of bounds. So update a trip set at. So like this constructs a new trip. Sometimes this is useful, but not always. Sometimes this is actually useful. So this function, I guess, a reference t to t. Iterate should take a reference, so we call this with a reference to that value. So I guess I'm going to keep the set at. Trip iterate this function f. Type check failed. Iterate takes a reference to trip. Add takes a reference to trip, I guess, too. Add reference to a. In this case, it's kind of, I don't know. Not sure yet. Kind of doesn't matter right now. Okay, sorry, here also is a little bit of a weird implementation for this, but sure. Type check failed. So in this case, we do that. Iterate data left, data right. References. Well, back to the lists. Lists are compiled now, right? Okay, what about the other collections? We have the queue. So the front of the reference to the queue is a reference to t. The length, we take reference here. Pop takes a reference to the queue and just returns t, but it like panics here. Trip at first 0. Dereferenced. Yes, I don't know. Let's actually do this. No. a little weird here. Actually, okay, because I have references, I can implement queues easier. Actually linear. Like queues don't need, because I can do just a linked list now, right? I can just do a linked list. Queue. Because I don't need to do that. Yeah. Let's do that later though. Let's start by doing this first implementation. Split at this one. Rest. I do not return the rest. There you go. That type checks. I guess I did not move the set here, so yeah, we only have a little queue and the list. This did not work. There's still type check failure over here. Left is reference and right is reference. Good. I think the problem is somewhere over here. I don't have the proper... So this looks like the trip node, and this looks like trip node where left subtree is a reference to the node itself. So it is in this code for sure. Length left, length right. Length. That's a reference. Update left and right to be this. Panic out of bound. How about I try commenting this, for example, and say panic, right? I can kind of just do that. And by deleting code, figure out where the error is. Okay, just to make sure. Is it even in the list? Cast. Yeah, I guess. I just do cast here. Type check failed. At 5x sub var. It's when I'm substituting. For sure. Yeah, because we have type T. Oh, yeah, you know what I can do? I can just rename T's to other things, but it's where I am creating a new one. So it's either a split or it's a merge. I guess it's a merge. Left, right, left, right, left data, right data. Let's rename this to merge T. So it's not merge T. Right? So what other T's do we have? This over here, singleton, single T. Nope. It is not. I'm not sure. I mean, let's try all of this. This is going to be at t, set t, update t, iter t. See, it says t, split t, merge t, length t, create t. Type check failed. Wait, so like the only t's are over here, right? This does not contain any references. And that makes no sense. I mean, oh wait, it makes sense because it's somewhere over here. It's either in the list or it's in the queue. That makes sense now. Because split trip at requires a reference. I found it. It would be like, yeah, my error messages needs to be improved. Maybe some other places because length queue trip at queue. Yeah, hold on. This now takes double reference, which makes no sense, right? Of course, trip at is a thing that takes a reference. I can try commenting the queue. And then commenting the list. Okay, comment everything. That makes no sense now. Type check failed. No! Reference and not reference. Trip. Let's try commenting this. Let's try and commenting these things by one. That works. Create. Should work. Let's try singleton. It also should work. Length. Should work. Right? Okay. So it's merge. Probably. It's not merge. So it's split at. Or is it at? At's implemented in terms of split at. Let's try just split at. It's not split at. Is it at? It is at. Okay, what's the problem here? We have at. This should be like a reference v. So I do reference v. Oh, yeah, and over here I should not do reference. I see it. I see the problem. It's like weird. Yes. What should actually be the thing here? Split add, because like this potentially. I don't know what I want. Let's say that this should be like right, and then index and right, and this should be like you know, like at index and right, and this is like at index. We split at index and right. It's because the variable name is the same. Made a bug. We just match at index here, like that, right? By the way, like, so because this splits, it will create a new thing for me, which is not correct, which means that this implementation is wrong. This implementation is actually wrong. Yeah, I feel like I need to rewrite this completely. Let's do the rewrite here. So basically, if index is equal to, I guess, okay, let's match v with empty. Then we panic out of bounds, of course, right? And then otherwise should be easy, right? Otherwise we say that if it's node v, then if index is equal to count to length. Is it count? Is it length now? I guess it's length now. Length of v left. Then I should return the reference to my current node value, right? Otherwise, if index is less than length of v left, then I should return at v left index, and otherwise we return at v right and index minus length v left minus 1. Right? Something like this. Not actually sure if this is going to work. So this type checks now. The example doesn't work. Type check failed. Because iterate takes this by reference. And dbg print. So now I'm going to be printing the references though to the values, right? So yeah, it's going to be 3 references to 3 variables. I'm actually wondering, are the references stable right now? So if I push, are the references going to be to the same things? It looks like they are. Okay. I think that makes sense for the current implementation. The references are stable. Yeah, but what we need now is, in order to like print these things, we need to say, you know, oh wait, I could do also a pattern, which is a reference, by the way. Yeah, because this is a reference, you know, x. So we need to dbg print x dereferenced now. But I think having a pattern matcher so that I can pattern match a reference would be nice. Let's do that. Use references in std collections. Yeah, let's do this instead. So like similarly to Rust, we can do like reference x and then dbg print x a little bit like this. But this doesn't work because ref must be expression. So I won't have a pattern reference, right? Yeah, so pattern reference. And we have pattern inside, right? Pattern reference, pattern inside. The order matters for the declarations in OCaml. So if I have a pattern reference to inner, then we do then we print reference tuple print pattern options tuple make inner. So when we have interpreter and I'm trying to pattern match against a reference with the inner pattern here, right? I need to make sure, yeah, I'm going to match place, claim, span, value, await inferred. I mean, we just like expect, yeah, we just expect this to be a reference, right? And if it's not a reference, then we error out saying expected a reference. And if it is some place, then we pattern match recursively. Span place with the inner pattern, and in this case we say error place expression error place. No, not error place. What do we do in this case? What do we do in error cases? Meshed false and empty. Okay, and when I initialize the pattern reference inner, then we say that the type of this is a reference to inner type, right? Yeah. If we do inject pattern bindings of pattern reference inner, then I should just inject pattern bindings of inner, right? Only compiler inner. If I am doing inner compile with handler, if we have pattern ref inner, then handle pattern inner. If we have the transpiler, we just reference fail with lock. I feel like I either need to delete the transpiler. I probably will do it from scratch. I don't know. Okay, ref must be expression. So now in the core syntax, ref must be expression. If this over here is a pattern, I guess we do like assignee. If it's assignee, ref cannot be assignee because you cannot assign to a reference, right? But if it's a pattern, then we will say that it's a pattern reference. Decompile pattern place init pattern span state like so, and then I guess maybe like this should be just called inner. So now this just works. We can pattern match to a reference. Nice. References as patterns. Well, I mean, technically, shouldn't dbg print also, like, I should, like, now that I have the references, I'm printing the values. I only need the reference in order to be able to print a value, right? Like, technically, this should be a reference here, but I think I will do these things later. For now, we do that. Ah, this is huge. References. Reference patterns. Yeah, let's commit. Let's go back to the advent of code and see how much of that stuff is breaking. We'll just do nix flake update cast. I have a feeling it's going to be slower actually instead of faster now because yo, Rondev, hello, thank you for the raid. I'm about to end the stream though, I think. I'm finishing what I was doing. What are you doing? Advent of code in Rust. Oh, nice. And then trying to learn Gleam. I see. Yeah, so I'm making a language like Rust, and I just implemented references, place expressions, and like stuff. So I'm going to update my existing Advent of Code solutions to use my new things that I just implemented. So right now we're going to see over here that and the things don't compile anymore because I have type checking issues, because now I have lists that actually can be mutated. So we say map is create a list. I create this. So pushing back is just the thing that has an effect. I push back two chars. I guess like maybe I should have made this syntax with like mutable reference to chars. I don't know. Not sure actually. How much of a leap would it be from Rust to cast? Like I feel like from Rust to cast should be pretty easy. Yeah, like once cast is done. I have a lot of like syntactic differences, right? So if syntax is something that can stop you, then yeah, I'm not really like trying to copy Rust syntax. I'm trying to copy Rust semantics, and improve on them, right? I mean, like the main feature from Rust is like the borrow checker, I guess. The other things in Rust exist in other languages. So yeah. For now, I'm doing the references, but I'm not doing it with the borrow checker. And I'm even allowing to mutate things that are not declared mutable for now. That's going to take some time. But yeah, now I just mutate the things in place instead of creating the new list when I'm adding the thing to the list, you know? So yeah, list at map I. So at returns the reference actually. Now I don't need the set at anymore, right? This is day 4, so list length map, list at map 0. This over here, set at ij. So set at is basically that at ij. This gives me a reference, and I just say that this is equal to 0 after dereferencing. So this is a little bit annoying though, that I should now put this in parentheses in order to dereference, right? That's why Rust has the indexing operator, which is just syntax sugar for this dereferencing. Barbarian just cannot handle functional languages, so as long as it's not more functional than Rust, I'll have to try it when it's closer to finished. Yeah, I mean, I'm trying to make it not like nerdy functional language, right? I'm trying to make it accessible. So like, as you can see, we have a for loop, right? Functional languages don't do that. So yeah, I'm not trying to advertise my language as functional, even although it technically, like, we had this conversation before. I don't even know what a functional language is. A functional language is like more a mentality than the language. It's like the way you write code, I guess, in an immutable style or whatever. I have no idea what it has to do with functions. It's like because of the lambda calculus and stuff, I guess. But yeah, I'm just trying to make it a normal human programming language, you know, not for the guys with PhDs. Q push to the Q, we add that. Q, what is Q? Q is Q create, yeah, Q push. Q push. Oh wait, Q push. This is the standard library. I forgot to change the Q. Let me change the Q. Q, oh wait, yeah, I was going to make the Q also, I mean, but that's implementation details, yeah. Let's just say that this does not return the new Q. When I'm pushing, I'm just taking the reference here, right? And I'm just saying that I'm going to do the merging here, yes, and I say that Q is equal to this, right? Yep. When I pop, so pop actually was changed already. That was the only thing that was missing. Past, let's see, that Q is Q create, std collections, Q create, Q, no, we don't have methods yet. Use std collections, Q, Q push, Q1, Q pop, Q is going to give me a 1. If I pop again, wait a second. This is bad because I need to say that Q is equal to rest, right? Okay, it's good that I tested it. You create, you push, you pop, you pop, you pop, you pop. It doesn't work. Shit, what do you mean? I feel immutability is really the core functional feature. Yeah. But like again, a lot of the languages that call themselves functional are not having immutability as their core feature. Like OCaml. OCaml is a really mutable language. There's a lot of mutability happening in around like the places, you know. What's the problem here? Delete at Q. Q is rest. And I return that. Q. Q pop. Maybe it was not saved yet because of the formatter. Sometimes that can happen. Yeah, actually, that is actually exactly what was happening. Fix Q. Right, let's see. Push. Reference and T. Yes, Q. Q. So we have Q. Q push a reference to Q. Here. And we don't assign it anymore. We just do that. Q length. We get a reference to Q here now to do that. When we pop, we do that. And we don't do the new Q anymore. We just do that. It mutates and returns the thing. Next. And that's all, right? So this is the day 4. Let me see day 4. Day 4. Day 4. It says type check failed. Reference to char is not char. Over here. At IG. Oh, yeah, because this is now a reference. That makes sense. So I need to dereference it, which is a little bit annoying, to be honest. Maybe I should think about like a different syntax. I mean, I can just change the function to return the value instead, right? And then have a separate function that returns a reference. Yeah, this seems like this still works. Part 2, 13 and 43. That was the correct values for the advent of code, right? 13 for the example and 43 for the part 2. I feel like that works, right? Let's fix the other days too, just so that they keep working. Main. So what do we have here? We have lists, right? Result is list create, so I'm going to push back to the result, this thing, and then a return result. Result is a reference here, but it's probably because I list iterate. Input is a read input, read input is a result. Yeah, so I need to iterate over the result like this, and this is my instruction. Okay. So let's do part day 1. Then must be expression. Then must be expression in the pipe, because okay, yes, then must be expression, but this is a place. So yes, that makes sense. Let me fix that. Core syntax. Then we say then must be expression, but it can actually be a place expression here. Place expression. Then we do place expression. We do compiler temp expression module C. This thing should be called C module C IST. Compiler. See. Right. Cast. So basically I should be able to just pipe let x be let f is x into x. Let x be 1 into f. X is 1. Okay, nice. Fix then as temp base expression. Sorcerer. Low. Day1. Okay, day1 works. Day2. Day2 probably has something similar. Oh, day2 is when we have the set. I should move the sets into the stuff, right? But we have this and we have that. Trip, iterate, trip, merge, and yeah. Is that all that I need to do for day2? It seems like that is day2 working, and then day3 needs also positions by digit. Is pushed back to here. List update. So list update is not necessary anymore because we instead just say that let positions be list at positions by digit digit, right? And then we say that, and we say let first is q pop positions, and then we just do that. That is all. Literally simplifies this thing a little bit. And then over here we do the same. We say that let positions be list at positions by digit digit, and then say q push positions position, right? Like so. That's already a reference, so that should work. Positions is list at positions by digit digit, q length position, q front positions. Okay, I think that's all, right? So day3, no, not all. Type check failed. This is not reference. In main over here, max in range, there is at, because this positions. It's because q front gives me the reference, right? But index is the front. Dereferenced, because I need the value here, not the reference. There we go. 357. Part 2 is all of these. Was that the correct answer for day 3? 31219. Feels like that's the correct answer. Okay, so and now we don't have any problems. Nice. Datecast. Oh, that was a long day. I did a lot of progress. So I'm going to go rest now. Ba-da-dum-ba-da-dum.
product is when two groups are combined
See you guys next time. Bye.
together using